Welcome to Food Security in a World Full of Infections, a University of Melbourne Public Lecture by Professor John Fazakerley. Professor Fazakerley is Dean of the Faculty of Veterinary and Agricultural Sciences, and this presentation is part of the faculty's 2016 Dean's Lecture Series. In this lecture, Professor Fazakerley discusses the threat diseases of plants and animals pose to our food supply and the tools we can use to guard against infections.
Hello, can everyone hear me? Great, thank you. So, good evening and welcome to this public lecture, Food Security in a World Full of Infections, to be presented by the Dean of the Faculty of Veterinary and Agricultural Sciences, Professor John Fazakerley. I'm Brian Leary and I'm Deputy Dean of the Faculty. The campus is located on the land of the Wurundjeri people, and the University of Melbourne acknowledges them as the traditional owners of the land. Before we begin, a bit of housekeeping. In the case of an emergency, unlikely, exits are at the rear to my left, through the doors, and the assembly point is that Brick Road, Professor's Walk, and most of you would have come up on that road tonight. The bathrooms are out through those doors as well, if needed. And also, if you haven't done so already, could you please turn your phone off or onto silent? Would be most appreciated. Professor Fazakerley joined the university in July after a worldwide and very long search for a leader with the skills, experience and expertise to take the role of Dean. He brings more than 35 years' experience as a director, academic and researcher into infectious diseases of animals. Prior to joining Melbourne, he was director and CEO of the Pirbright Institute in the United Kingdom, which focuses on research and surveillance of viruses of livestock and viruses which can spread from animals to humans. Before this, he was Professor of Virology at the University of Edinburgh's College of Medicine and Veterinary Medicine. The purpose of today's presentation is that it's part of the Dean's Lecture Series of the Faculty of Veterinary and Agricultural Sciences. And the main purpose of this lecture is to allow a prominent speaker to bring issues of importance to agriculture, food and veterinary medicine to the attention of all of our stakeholders. And for that, I would like to thank you for coming tonight, whether your relationship to the university is new or old. Tonight's topic is a really important one for all of us. Viruses and other diseases of crops and animals have the potential to put our food supply at risk and cause great damage to agricultural industries. The same ease of movement for people and products around the world that fuels our modern economy inevitably introduces risks to our ecosystem and food security. That is, our ability to ensure physical, social and economic access to sufficient, safe and nutritious food. In tonight's lecture, Professor Fazakerley will apply his academic expertise to address these risks through examples of some of the diseases that threaten our food security and what we are doing and could do to safeguard against these threats. We will hold a brief question and answer session after this lecture. Now, if you'd like, I'd like you to join me in welcoming Professor John Fazakerley to the stage.
Well, thank you, Brian, for that kind introduction, and let me thank you all for coming along here this evening. It's a great pleasure to be the new dean of this distinguished faculty with so many excellent students and excellent staff and excellent alumni and supporters. So thank you all for coming along this evening. I've chosen to talk on this topic of food security in a world of infectious diseases rather than the other thing which I had thought about talking about, which is zoonotic virus infections and how the diseases go from animals to people. And I think, but the two are somewhat linked, and you will see some links in this. So, food security in a world full of infections, then. This is, of course, what we want. We want good, healthy crops, good, healthy animals, and this is the challenge. The food security challenge of the 21st century. Food security exists, according to the Food and Agriculture Organization, when all the people, at all times, have physical, social, and economic access to sufficient, safe, and nutritious food. And we don't start from a good position because 30% of the world's people are already starving and the population is increasing hugely. The Food and Agriculture Organization estimate that global food production must increase by about 40% by 2030. That's not very long. And by 70% by 2050. And that's got to be against the background where we've got 30% of the world already starving and the population is increasing. It's going to be against the background of a competition for water resources required for the animals and the food, competition for good quality land, as Melbourne, for example, edges ever further to the west, so the horticulturalists and people get pushed out. The west of Melbourne used to be a big dairy area, lots of grazing there, for example, doesn't happen anymore. So there's a competition for the land. There's environmental change going on. There's climate change. The soil in some parts of the world is denuded and no longer healthy and no longer capable of supporting the crops. We've got changes in food consumption as people in different parts of the world change their eating habits and have better diets and demand higher protein and more animal protein, for example. And there's an increased threat from pests and infectious diseases. And that's the bit I'd like to concentrate most on. But first, let me just put it in context. This is the FAO's hunger map. These are the areas of the world in which, let me turn the lights down just a bit at the front. These are the areas of the world in which there is currently undernourishment of the human population. And you can see that that's parts of South America, it's Africa, and it's Asia and Southeast Asia. So some of the world, as I said, is already undernourished. And then the world is increasing its population. So we currently have 7.5 billion people in the world. And that population is predicted to increase to 9.7 billion, so that's another third, roughly, by 2050. And you can see that on the graph below here. This is where we currently are. So this is us in 2016, 7.5 billion. And these are the predictions from the United Nations for 2050. We'll look at the red line, which is the median prediction, and the prediction is nearly 10 billion people. So it's this gap here that we have to feed. But we have to do it when the water is a major challenge. So we have to cope with floods and droughts, we need clean water, and we have to deal with less water to produce the food. This is another map from the FAO, and it shows the areas of the world which are already extracting huge amounts of water for agriculture. So the darker red the colour, the more water in that area is already being extracted for agriculture. And you can see in the Indian subcontinent and parts of Africa, over 90% of the available water is already being used for agriculture. And on the left is, I think, a rather nice little list of how much water it takes to produce certain kinds of food. It takes 13 litres of water, for example, to produce a tomato, but 2,400 litres to produce a bar of chocolate. So think about that when you have your chocolate. This is another interesting piece of background data on this whole issue, and it's the predictions for how the changes in climate will affect agricultural production. So this is 2080, and the areas that are green are areas that will produce more, potentially, and the darker green, the more they're likely to produce with the climate change, and the areas that are red are going to produce less. So you can see that climate change also produces a big challenge to producing the extra food. Oops. And already feeding the global population is responsible for 25% of the greenhouse gases, which are partly causing the global warming and driving the population, and feeding the population is driving the deforestation of some parts of the world, which of course is also contributing to the climate change. And there's also loss of biodiversity, land degradation, water overuse, and pollution. So as we intensify our agriculture, we exacerbate things. In Australia, agriculture is a major producer of CO2. It produces 16% of the Australian total of CO2, produces nearly 60% of the methane, and 77% of the Australian total of nitrous oxide. So agriculture itself is damaging the environment to some extent. This is Australia, of course. And if we look on the left, this is 1990 to 1999. It shows the rainfall patterns. And the pink areas are summer rains, and the blue areas are mostly winter rains. And you can see that if we look at the next decade, or the next 15 years, 2000 to 2015, the summer rainfall has moved south, and the winter rainfall has moved south with it. And Australia has experienced, over those 25 years, a change in its rainfall patterns. Having been here for 3 months, it seems to me in these first 3 months, it's nothing but rain. And I'd note that parts of Victoria are now flooded, whereas when I went out to the university's farm at Dookie, and when I visited last November, it was all very parched. So there's a background there of climate change, population, the challenge of feeding the extra population. And now I want to concentrate for the rest of the time on the challenge of pests and diseases, or actually just diseases, but I thought I would mention pests lest we forget them. But pests are a major threat to our agriculture as well. And there's an estimate that globally, 20 to 40% of agricultural production, so against this background I've been talking about of us trying to produce enough food, 20 to 40% of it is lost through pests and diseases. And what exacerbates the pests and diseases? Population growth, extra people, the environmental change, and globalization, the way we move around the world and the way our goods move around the world. Let me illustrate that, if it works. Some of you may have seen this before, but I think it's a rather nice illustration of the way that the world is globalized. Every yellow dot is an aeroplane, and where it's dark, you can see the sun moving, and where it's dark is night, and where it's light is daytime. And we're just coming into morning in Europe, and all the aeroplanes are starting to get going into the skies in Europe. It's lighting up yellow, and it's starting to go nighttime in Australia, and Australia is shutting down with all the yellow is going away. And now it'll be dawn in North America, and suddenly all the air flights will pick up in North America, and so we go on. But the number of flights per day is just amazing. The world is so interconnected. And here's something that's jumped around the world in its interconnected way. And some of you will put your thinking caps on and know what this is. So this was, before 9/11, this was the biggest thing in America. And this was a virus that came from Africa and suddenly jumped from Africa into North America. And if you'd asked the Americans what were the biggest threats on their radar, they would not have said West Nile virus. They'd probably never heard of it, and it wasn't really something they were worried about. But it's now spread right across the continent of North America, and it causes encephalitis in horses and people, and it'll probably never go away. It'll probably just become endemic now. Global shipping also interconnects the world, and this is a similar video taken from the internet of the traffic in shipping. And again, this one comes with sound. Yeah. Okay, we'll have the sound for a minute. But here you can see the Malacca Strait just near Singapore, and you can see all these ships moving around. Some of these are the huge container ships we see coming out of Port Melbourne. They're carrying agricultural produce, and they're carrying people. When I played it on my desktop, I had the sound turned off, so I didn't realise it did that. But you get the point, that there's huge amounts of movement of ships around the world. And here's something that hitched a ride. This is the Asian tiger mosquito, Aedes albopictus. This originally started off over here in Southeast Asia. This is its home. But it hitched a ride in the trade of lucky bamboo that was being exported around the world, and also in the used tyre trade. It's difficult to dispose of used tyres. So they get put on ships and they get transported around the world, and they all hold little bits of water, and the mosquitoes breed in the water, and the mosquito larvae for Aedes albopictus went with them, and now it's all the way around the world, as you can see. Everywhere that's red now has Aedes albopictus. And this is a mosquito that likes biting humans, and this spreads dengue, chikungunya, and Zika. So it just shows you how these things can be moved around. Let's talk about crops and the diseases that we have to contend with, or a few of the diseases we have to contend with our crops. So crops of global importance include wheat and rice and potatoes. Those are the three most important crops in the world. Here's the world production. The world produces about 740 million tonnes of wheat, 500 million tonnes of rice, 330 million tonnes of potatoes. And potatoes, particularly in the developing world now. And from the graph on the left, you can see, if you look at the orange line, that production has been going up from 2006 to 2016 in cereal production. So it's been going up by about 600 million tonnes there from 2000. So it's gone up, but it needs to go up some more. So agriculture is becoming intensified, and these are the three important crops. And this is one of the big threats, rust. It's a fungus. The orange bits you can see on the stems of the wheat here are the rust fungus. Wheat rust is Puccinia species. It occurs worldwide. It infects wheat and barley. And wheat provides 1/3 of the calories that we eat globally. It's the most important disease of wheat on a global scale, and it reduces growth and yield. In the 1950s, it first came to prominence and destroyed about 40% of the crop in North America. That's a huge reduction in the crop. So resistant varieties were bred by conventional sorts of breeding techniques, and new strains, new cultivars, new varieties were produced and planted, and they had resistance to rust. And more recently, the plants have been genetically engineered so that they have resistance to this fungus. But then in 1999, along in Uganda came a more virulent strain of rust known as Uganda 99. And most of the wheat varieties planted in Africa were susceptible to UG99. And the rust spread from Uganda out to Kenya, Ethiopia, Iran, Yemen, spread by the wind, for example, and it's a major problem. If it enters the United States, the US Agriculture Department reckons it would cost their agriculture industry about $10 billion. We have strains of rust in Australia. In Western Australia, for example, there are annual losses of 10 to 50% from rust. Or if it occurs early in the season and it's not controlled, there can be very high losses. So we're trying to produce all these crops, but the diseases are there and are thwarting our efforts. And rust is easily spread. Here's a harvester, and you can see the plume of orange coming out the back of the harvester. Those are all the rust spores, and they'll get dispersed by the wind, and no doubt that's how it got from Uganda up across the Horn of Africa and into the Middle East. And you can see on this person's trousers here and their boots all the rust spores. So it's easily spread. Here's another one. I said potatoes were the third biggest crop in the world these days. This fungus, the potato late blight fungus, this fungus was the sole cause of the 1845 Irish potato famine. You've probably heard about the Irish potato famine. Potatoes were the staple diet in Ireland in the middle of the 19th century. And the crop became infected with this fungus, the potatoes couldn't be eaten, and 1 million people starved to death, and 2 million people emigrated. And if we actually look at the population of Ireland, you can see that. You can see it on the population graphs. Here's the population of Ireland, it's doing very well, population's increasing, they're eating lots of potatoes, and then the famine comes along, and there's 1 million people dead and 2 million people left. A fungus. And we have plenty of other diseases. Obviously, I don't have time to go through them all, but On the papaya here, you might just be able to pick out the little circles. This is papaya ring spot virus. This one's a fungus of capsicums. This one's a pyrethrum fungus. Pyrethrums are important for making insecticides. And here's a fungus of apples. You're probably not going to pick these off the counter in Woolworths. So there are diseases of plants in not just big crop industries, but also in the horticulture industries. And these diseases can become widespread and very problematic. Bee diseases have been in the news in North America and in Europe, and perhaps less so in Australia, but you may have heard about the varroa mite. So here's a list of bee diseases. I don't intend to go through them, and it's just some of them actually. And bees suffer from a number of different things. They can suffer from protozoan parasites, they can get fungal infections, they get virus infections, they get bacteria. And bees, of course, are important for pollinating the plants. So if we want all our crops growing, we need to have the bees. So here's a quote from the Department of Agriculture. If the varroa mite were to become established in Australia, our healthy population of feral honeybees and the pollination services they provide could be reduced by 90 to 100%. Now, we don't have the varroa mite. Well, the varroa mite's not widespread in Australia. There have been some recent incursions which have hopefully been dealt with. But varroa mite is a big threat to the bee population of Australia. So what about the animals? We rely on the animals as well for our food. What about diseases of animals? Well, livestock productions around the world occupy around 30% of the planet's ice-free terrestrial area. So we use a lot of our land for animal production. And livestock products account for 17% of our energy consumption and 33% of our protein consumption. They're important for us to have. And as the population of the world expands, it's also changing its eating habits. And more people are eating a richer diet, which includes more animal produce. The graphs on the left just show, again, just like with crops, just like with cereals, that we have been increasing production. So if we look at the number of chickens, this is numbers in billions, and this is 1960, and this is where we are now, the numbers of chickens being produced around the world has gone up considerably, from 4 billion there to 16 billion. That's a 400% increase. And here is the weight of the chicken carcasses. So the chickens have been getting heavier as well, as they've been fed more. And this is egg production down here. And then the same is true for cattle. The number of cattle has gone up over the last 50 years, and the weight of the cattle has gone up, to start with, early gains in the 60s, but less so recently. And this is milk production. And as we know, milk production has been an issue around the world, in that the world is currently actually probably producing too much milk. Pig numbers have gone up. The carcass weight of the pigs has gone up, and the same for sheep and goat. So we're doing well as a world agriculture system. We have over the last 50 years been producing more food. But we're still going to have a 30% increase in the population of the world after what we've already done. So we have to do more. And livestock has its diseases. So I'll put this one out as a little test. Who knows what this is, in your mind at least. This was the disease that defined modern veterinary science. It got lots of vet schools set up because it was such a problem. It was responsible for founding the world's first veterinary schools, the British State Veterinary Service in the 1850s, the World Organization for Animal Health, which is the equivalent to the WHO, and the FAO Animal Health Service. It was a disease that was widespread from Africa through the Middle East into India, Pakistan, the whole Indian subcontinent. Who knows what it is? It's rinderpest, yeah. Cattle plague. This would wipe out your whole cattle herd. And it's a success story. This is a medal that I received as director of the Pirbright Institute in my last job from the FAO for the Institute's part in getting rid of this disease. This is the second disease to ever been eradicated from the world. The first is variola, which causes the disease smallpox. So variola virus, variola major, causes smallpox. And rinderpest causes cattle plague. Rinderpest is the second virus to have been eliminated from the face of the earth, apart from the stocks in people's freezers, actually. But that's a win. That's a success. But it was a big reason why cattle production was not highly successful in Africa. And here's another one why cattle production is still not highly successful in many parts of Africa. This is tyleriosis. Tyleria is a small parasite. It's a single cellular parasite. This is it blown up down the microscope hugely. And this is what it's spread by. The rhipicephalus tick. The ticks get onto the cattle, they bite the cattle, they put in the parasite, and the cattle die. It's also called East Coast fever. It's a major disease of cattle in Africa, and you can see the countries there in Africa that have this disease. It's a natural infection of African buffalo, but it doesn't do anything in the African buffalo. It only causes disease in the European and non-African strains that have been introduced into Africa. The Food and Agriculture Organization estimates that it causes the annual loss of over 1 million cattle, mostly in Africa. And how about this one? This, of course, is foot and mouth disease. Foot and mouth disease 2001 in the United Kingdom. You can probably tell by the accent I'm British. And I vividly remember driving around the countryside and seeing all the pyres of burning animals everywhere in 2001. Foot and mouth disease affects sheep, cows, and pigs. Pigs generate the most infectious virus, actually. They breathe it out, and they're a big problem for spreading the virus. And this infection started in a farm in Northumberland in 2001, but we hadn't had an outbreak in the UK for many decades. And so the vets were not good at recognizing it, and we didn't have any controls or any big controls on our movements of animals. Quite a lot of abattoirs had been closed down not long before this, and animals were transported long distances to markets. And what happened at the markets is they were all mixed up, and the disease was very rapidly spread around the country. It was spread around the country before people really knew what was happening. And this epidemic in 2001 of foot and mouth resulted in the slaughter of 6.5 million animals across the UK on these burning pyres of animals, and affected nearly 10,000 farms. And it cost the economy £8 billion. So it's huge. And the reason that foot and mouth is huge when it arrives is that in a country like the UK or Australia, all the animals are naive. It's like having this lecture theatre and you put in the virus, everybody's naive, everybody gets it. So when it arrives, it's a very big problem. And we had this problem in 2001. So these are the endemic areas of the world for foot and mouth. The areas in white are free, and the areas in red are endemic for foot and mouth. And if you're endemic for foot and mouth, you can't export your meat to areas of the world that don't have foot and mouth. So a big problem for the UK in 2001 was it couldn't export its meat. And then the red dots are areas of the world that don't have it, where there have been outbreaks in an 8-year period there. So it's got a relatively low mortality, but it's got a high impact because it affects so many animals, and it produces production losses, and as I said, it produces trade losses, and it produces tourism losses, because when you close down the countryside, because you don't want people walking around spreading the infection, that affects tourism, and that's a major cost. And the OIE estimates that economic losses in endemic regions, areas of the world that have foot and mouth, due to production losses, are probably in the order of $21 billion per annum. And outbreaks in FMD-free countries, which happen occasionally and cost a lot of money and then don't happen for decades, the OIE reckons that they cost annually about $1.5 billion. So it's a major economic cost, foot and mouth. The US government estimated that if there was an outbreak in California, it would cost them maybe up to $13 billion to control it, and that would be just California. Australia hasn't had an FMD outbreak since 1872. But the Department of Agriculture and Water Resources estimate that a small outbreak in 3 months could cost the economy $7 billion. But a large outbreak would cost significantly more. Pigs have their diseases too. Pigs also get foot and mouth, but this is one that's currently a problem in North America. Porcine epidemic diarrhea virus. It's a severe diarrhea of pigs. The older animals get a bit sick, but the piglets die. And this is currently a big problem in the US. And here's another pig disease, which everybody's currently very worried about. This is African swine fever. It comes from the pigs that are the natural pigs in Australia, the bush pigs, but they don't get sick. Again, it's a virus that's adapted to its host in Africa. The natural hosts don't get sick. But if you introduce the commercial pig breeds into Africa, for example, they will get African swine fever. And like many viruses, it's made its way out from its natural home of Africa over recent decades. And there was a big outbreak in Cuba in 1971, which resulted in them having to slaughter 500,000 pigs to get rid of it. There have been outbreaks in Spain and Portugal in Europe. But the thing that people are worried about at the moment is the outbreak that happened in the ex-Soviet republics along the border with Europe starting in 2007. And these were outbreaks in a Red Army farm. And the Red Army have their own farms, and their pigs start to get sick. So what do you do if you're the Red Army? You kill the pigs and you feed them to your other pigs. And so they then managed to spread the disease right the way along the whole series of farms that they had. From the Caucasus all the way up to the Baltic, and caused a massive outbreak. And since 2014, the virus has now come into Europe. Now, this is a hemorrhagic disease of pigs. It can be very fatal, and nobody has a vaccine. And so there's a big worry that this virus will jump into other parts of the world, and we have no real way of controlling it. It's also transmitted by ticks, which are pretty difficult to control. So those of us involved in animal health, we're always saying, well, what's next? Yeah, what's going to be next? So in the UK, this is what was next. This was 1986 to start with, and then 1987. There's a clear epidemic of something going on there. Some of you will know what that is. It was mad cow disease. And this was because people had changed the way that they fed the cows, and they were processing the carcasses of the cows, a bit like the Red Army story. They were processing the carcasses of the cows, and they changed the rendering process, and then they were feeding them back to other cattle. And this is a rather unusual disease, since it's an infectious protein, and it caused the mad cow disease. But as you can see, by 1996, the disease was pretty much under control until there was a link that it caused human disease. We had a Minister of Agriculture, I remember, on the television who forced his daughter to eat a beef burger and tell everybody it was safe. Then it turned out that it caused this variant CJD, Creutzfeldt-Jakob disease, which is a degenerative brain disease. And so the government acted by banning all cattle aged over 30 months from going into the food chain. And this resulted in the slaughter of 3 million cows, which was more than being slaughtered by the actual disease. And the UK sales of beef products immediately declined by 40%. Export markets were completely lost. The EU banned British beef for about 10 years, and it cost the country for nearly £4 billion. And then in 2001, we had foot and mouth, which cost us £8 billion. So agricultural diseases of livestock are no minor thing when they happen. And they're easily spread around. They're spread by the wind, they're spread by contact, they're spread by moving animals to markets, they're spread by, these are midges. Midges spread a whole series of diseases. Here in Australia, they spread Akabani, they spread blue tongue up in the northern parts of Australia. In Europe, some of you may be familiar with the Schmallenberg story. This was a virus that suddenly started causing the deformities in lambs and cattle. It was a midge-transmitted virus. And they transmit African horse sickness, which is a hemorrhagic disease of horses, which could, again, come out of Africa, has come out of Africa, but could spread further. This was blue tongue in Europe in 2006. There were various strains of blue tongue. There are 26 different strains of blue tongue. And in 2006, we had a strain came from Africa, blue tongue virus 8, and it spread out all around those parts of Europe and caused the authorities to kill and vaccinate lots of cattle. And my previous institute, we worked out that if we looked at the air movements, we could actually work out that the midges were blown across from Europe to the UK, and they would have landed in East Anglia there, those of you who are familiar with UK geography, and indeed that's where the first cases were eventually traced back to, exactly here, and that was the plume of midges when the air conditions were right that would have come over from Europe. So these things can be transmitted long distances by things like insects. So there are a lot of other infectious diseases of livestock. I've just put them up to make the point there's a lot. I don't intend to go through them. And now back to the food security. So this is the global meat demand in the world, and we're now here between 2010 and 2020. And look at the green bars. So one of the things that's going up a lot is poultry. We're all eating more poultry, and the demand is for poultry. Poultry is got the biggest increase in consumption. So poultry have their diseases too, and without me going into lots of them, this is just a list of all the some of the viruses that affect the poultry industry. And when you have a poultry industry like this with 500,000 chickens in a shed or something like that in big poultry facilities, when you get a virus in there or a bacterium or some other disease, that can wipe out all of your poultry. And the way that that's controlled is through vaccines, and there are a lot of vaccines that poultry get, and some of them, in some places you can vaccinate the embryo and the egg, so the eggs get vaccinated. And it's important to do this because if you don't, your poultry shed can look like that. And there's a number of viruses. I don't propose to go through the text on these, but infectious bronchitis is one that's found worldwide and causes losses in production. And then there's this one. Yep, you've got it, avian influenza, bird flu. Bird flu is a natural gastrointestinal infection of birds. It passes down through the gastrointestinal tract. It doesn't cause much disease in most birds, in waterfowl, for example, where it's a natural infection. And there are two types of influenza, low pathogenicity and high pathogenicity. And influenza viruses, by the way, affect most mammals. Horses can be a problem. Obviously, it's a problem in humans. It's a problem in pigs. They'll infect whales, for example. And this is one, just to pick on one influenza virus, this is one that there's been a lot of concern about, H5N1. Why is there a concern? That's on the bottom line. Since 2003, there have been over 700 human infections, which is not very many. But the mortality rate is 60%. So get this, your chances are you'll die. So for human health purposes, there has been a big campaign to eradicate H5N1. And between 1996 and 2010, over 62 countries reported outbreaks. And between 1996 and 2003, in that 7-year period, 43 million birds were destroyed to get rid of it. But in the next 3 years, over 250 million birds have been destroyed to try to make sure we get rid of H5N1. And of course, these are birds we can't eat, and eggs we can't eat, etc. And the economic consequences of this are huge. And just to take one country here, Vietnam, 44 million birds were destroyed, for 17% of their population, at a cost of 120 million, which is a lot of money in Vietnam. So just fighting this human disease, and there are strains of influenza which are very important in the poultry industry, and there are strains that are important in the pig industry too. But fighting influenza is a constant fight. And we're now getting more and more of our food from aquaculture and fisheries. And in fact, aquaculture just recently has overtaken fisheries as the main source of fish. And aquaculture is the fastest growing food source in the world. And you can see that in the graph on the right. This is the increase in aquaculture production since 1990 here to 2010. And you'll see there's a lot of increase in fish, mollusks, crustaceans, and actually aquatic plants as well. And this has its diseases as well, lots of them, don't want to go into them all again. But, for example, oysters are difficult to grow around here because of this little parasite. And salmonid alphavirus is a big problem, for example, in the fisheries in Northern Europe. And white spot syndrome, this is a shrimp here with white spot syndrome, is a problem with the cultivated shrimp industry in, for example, Southeast Asia. So, throughout the food that we eat, we have the challenge of infectious diseases. But it's not all doom and gloom because, as I said, we already eradicated rinderpest. So we can do that with other diseases. And there are lots of things we can do. So how do we do that? Well, we need good international and national surveillance. It's important for us to know what diseases are out there and where they're moving. We need this coordinated, and organisations like the OIE, which is the WHO for animals, and the FAO for crops are doing this kind of thing. We need good diagnostics. We need to know what's out there. We need to be able to detect it rapidly so we know that there are outbreaks. We need plans for what we're going to do when these things come along. We need a plan for what will happen if foot and mouth comes to Australia. We need to maintain a capability to deal with it. We need cooperation agreements between industry and government. So, for example, industry doesn't want to stockpile huge amounts of vaccine that nobody's going to buy. Why would they? So government's got to pre-buy it and stock it. We need resistant species. I talked about some crops that have resistance. We need to genetically engineer them. We need to coordinate our research programs to make the vaccines. We need genetically engineered plants and animals. We need to use our pesticides, fungicides, insecticides, acaricides. They deal with ticks. We need vaccines, antivirals, antibiotics, and antihelminthics. Let me give you a couple of examples. Pirbright, where I was until I came here as director, we were the world reference laboratory for foot and mouth disease. That meant everybody in the world had to report to us when they had foot and mouth disease. We'd tell them what strain it was, we'd tell them how to deal with it, we'd tell them what vaccine they could use, but we coordinated it. And we made sure that all the laboratories around the world, all the other laboratories here, knew how to do the tests, knew how to send the samples, and could coordinate things in their country. We developed new pen-side diagnostics. You need to know quickly whether you've got an outbreak. These are some of those diagnostics. This one is for actually sampling the air and trying to work out whether there's virus in the air. This is like a pregnancy test. You could put it in a sample from the animal. And this just shows the animals have got hot feet, but they do, foot and mouth disease. So these things are very useful. You need contingency plans. This was the contingency plan for blue tongue, and we had it before it arrived. This is the Australian one for foot and mouth disease. There are a number of contingency plans in this country, you should be assured, for dealing with these infectious diseases. And biosecurity in Australia is a key part of this. So Australia is one of the few countries in the world to remain free of some of the world's most severe pests and diseases. And the Department of Agriculture and Water Resources screens, inspects and clears the millions of people, parcels, baggage, ships, animals, all those ships arriving I was showing you earlier, all those aeroplanes, all the containers coming in, all the machines, all the people, trying to stop the varroa mite, trying to make sure we don't have outbreaks of foot and mouth, trying to stop the different pests, trying to stop the different strains of rust that might come in, all these weeds and other things. So they do a very good job, and I think it's a very important thing that this country has. This is a list of some of the things that we don't have, that they're trying to keep out. You're not supposed to read it, it's just to tell you it's a big list. So biosecurity is important. And then what else can we do? Well, we can breed crops that are not susceptible to these diseases. So these are wheat strains which are not susceptible to stem rust fungus, that fungus I showed you that produced the orange powder on the stems. We can use fungicides to prevent the potato blight. Here's the potato blight I showed you. This is a plant that's got the potato blight. This is one that's been sprayed here with a fungicide, and it's not got the blight. We can genetically engineer the plants. The plants can be genetically engineered for drought resistance, for example. And more recently, in the last couple of decades, through fundamental science, we as a global scientific community, have understood the immune system in plants. It's totally different to in mammals. Nothing to do with T cells and antibodies and things like that. It works at the level of RNA molecules, and by understanding it, you can engineer a plant with the right kind of RNA molecule that when the pathogen comes, it's ready to fight it. And here's an example. This is a plant here that's been engineered to contain a particular kind of RNA, a hairpin RNA, which is against the potato blight fungus. And here's a wild-type one that hasn't been genetically engineered, and you give them the fungus, and these ones are fine. They've got their immune system switched on. And this is from this week's Science, very fortuitous, about all the different plants that have been genetically engineered. Corn, tobacco, soybean, poplar, lettuce, wheat, rice, potato, tomato, grapes, grapefruit, and some of them have been genetically engineered to be disease resistant, and that's this symbol. Some of them to be drought resistant, some of them to have consumer benefits, different kinds of oils and things. And we shouldn't be shy of this genetic revolution. And you can do it with animals now. This is Dolly the sheep. You might remember Dolly the sheep. I worked at the Roslin Institute for a number of years where they produced Dolly the sheep. These are chickens that have been given a green fluorescent protein, and pigs that have been given a green fluorescent protein into their genome, and fish. You can do it with fish. And this led to the engineering of chickens that don't transmit influenza, which is a major breakthrough. And we can do that with other diseases. And you can do genetic engineering on fish. And this is the first genetically modified animal, well, fish, that is being licensed for human consumption. It's the Aqua Advantage salmon. It grows much faster than normal salmon. This is the genetically modified one. This is the normal salmon. And the FDA in the US have said that this is genetically engineered. It's safe to eat for humans, and it's safe for the fish. So this will be rolling out onto dinner tables in North America before long. And finally, last slide also, the most powerful thing we have against animal pathogens, vaccines. And we have many vaccines, and we can vaccinate the animals to stop, for example, foot and mouth. But if you do that, you can't sell your meat. So we need better foot and mouth vaccines where you can tell whether the animal has been infected or whether it's been vaccinated. All the ones that are underlined, we need better vaccines. Rinderpest we've eliminated, so we don't need a vaccine for that. African swine fever, everybody desperately wants a vaccine. But vaccines are incredibly powerful. This is a project we did at Pirbright, my last slide, and it's showing foot and mouth disease virus. And because the scientists understood the molecular structure of the virus, they were able to change it, add in some additional covalent bonds in the capsids, and produce virus capsid molecules that no longer fell to bits, which meant that you could have a vaccine that was stable. And you could also produce it outside of high containment. And this will be the new generation of foot and mouth disease vaccines. So to summarize, infectious diseases of plants and animals are a threat to global food security. There's lots of them. The infectious diseases can be difficult or almost impossible to predict sometimes, but then we also know a lot of them. And we have lots of ways to deal with it. Vaccines, breeding and genetic engineering, improved pathogen detection, identification and monitoring, greater traceability of the animals. We now trace animals much better than we used to. Emergency planning and biosecurity. All of these things are important. And I'd just like to acknowledge a couple of my colleagues who helped me with a few of the slides. And thank you very much for listening.
Thank you for listening to this public lecture, Food Security in a World Full of Infections. For more news and information on the Faculty of Veterinary and Agricultural Sciences, you can visit us online at fvas.unimel.edu.au.